So in this case, we are going to consider again looking into our trigonometry, but this time focusing on the special angles, which others consider as special triangles because they are being taken from the special angles. So one way or the other. So when we are given this part, actually, we have got the angles such as the 0 degrees, the 30 degrees, 45 degrees, the 60 degrees, and also the last one, which is the 90 degrees, which basically gives us the special concept of our special angles from the right angled triangle. Remember, all this part is being taken on a right angled triangle. So of these angles that we are given, the basic one that we are going to be actually focusing is 30 degrees, 45 degrees, 60 degrees. But as an individual, guys, you are supposed to know what is happening on these angles of 0 degrees and what? And 90 degrees, as we are going to be working with our evaluations. You are going to see that it is important for you to understand that the sine of 0 degrees is going to give us 0. The cos of 0 degrees is equivalent to 1. The tan of 0 degrees is equivalent to 0. So this is the idea of our angles when we are at 0 degrees, working with those trig ratios, the three trig ratios that we talked about before, sine, cos, and the tan. So it also follows that even if we are to consider for the 90 degrees, the sine of 90 degrees is now equivalent to 1. It opposes with the cos. So the sine of 90 is the one which is 1, whereas the cos of 90 opposes the sine of 0 degrees. So it is going to be at 0. And the tan of 90 degrees does not even exist. It is undefined. We cannot simplify that one mathematically. We cannot simplify the tan of 90 degrees. As we can see, we cannot have a solution that is undefined. So those are the basic angles, actually, that you are supposed, as an individual, they can ask you any one of these. They expect you to know this, but even if you do not know, guys, remember in exam, paper 2, paper 1, if you've got your calculator, just use your calculator there. So at the end of the day, the special part of these special angles, we do not see it because of the use of the calculators nowadays. We are using advanced calculators that simplify exactly the same thing or the display that we want. Let's take an example of the sine of 45 degrees. We can have a simplified value, the square root of 2 over 2, which is exactly the one that you are going to have on these special angles. So at the end of the day, that's why, guys, I say I do not see what exactly the special part that we have got on these special angles. But anyways, for the sake of revision, so that you do understand the basics of these angles, I'm going to work out this part. All right, let me just try and have something like this. All right. So this is where we are going to take our angles from. Let's say we've got a 90 degree here, and considering an isosceles triangle, it is a right angle triangle, but it is isosceles, meaning to say these two angles, they are equal. Remember, I say these two angles, the remaining two angles, they add up to 90 degrees. And we are saying they are equal. So divide by 2, it will be what? 45 degrees each. For it to be an isosceles right-angled triangle. This will be 45. This will be 45 degrees. All right. So let's say we have got the sides 1 and 1. From the Pythagoras theorem, we do understand that we can calculate the third side. Using Pythagoras theorem, h squared is equal to a squared plus b squared, or you can take from c squared the way that you understand. So meaning to say the hypotenuse was going to be calculated, c squared is equal to, you take those sides, 1 squared plus 1 squared. So c squared, 1 squared is 1, 1 squared, that's 1. You add, that was going to give us a 2. So to find c from the c squared, introduce the square root. So meaning to say c is equal to the square root of 2, which is the hypotenuse. When we are given 1 and 1 like this, the hypotenuse becomes the square root of 2. That is where we are taking it from. So using this triangle now, we can simplify the trigonometric ratios of a sine, a cos, a tan of what? 45 degrees. As we can see, it is an isosceles triangle. So one angle is going to be used. As we can see, 45 or 45, anyone. So let's say I'm using this one as my reference angle, this 45 degrees that we are having here. Let's say this is our reference angle. Remember, according to the given angle, we can name the sides. So it means according to this 45 degrees, the one that is opposite to it becomes our opposite. And 90 degrees and 45 here, they are adjacent to each other. Remembering our hypotenuse always facing the 90 degrees, the longest side. So that is what we have there. According to this 45 degrees, if we were to name according to this one, it was going to change. This was going to be our opposite, and this was going to be our adjacent. So choose anyone. You are going to have same answers, so do not worry about that. So let's formulate these ratios and see. The sine of 45 degrees from the ratio of sine, remember that part of our SOHCAHTOA, sine opposite over what? Hypotenuse. Opposite over hypotenuse, which is 1 over the square root of 2, which can be simplified from our seds. Remember, we dealt with the seds, so we can rationalize the denominator. How do we rationalize this? All right, so it follows that if we are given this from seds, 1 over square root of 2, we rationalize by multiplying by the square root of 2, both the numerator and the denominator. So that's 1 times square root of 2 is going to give us square root of 2. Square root of 2 times square root of 2, remember square root of a times the square root of a is equal to a from our laws of sets. So this one times this one is a 2. So meaning to say, as a simplified answer here, this will give us square root of 2 over 2. So this is sine of 45 degrees, which is exactly the one that we can see from our calculator here as a simplified value. So you see, guys, at the end, you see there is actually nothing about these special angles, because exactly what I'm getting on my calculator, that is exactly what we see here. The same if we're going to do that one for a cos. The cos of theta adjacent over the hypotenuse, according to our diagram, adjacent is 1 and the hypotenuse is square root of 2. So definitely these two are exactly the same. So it was going to give us square root of 2 over 2, just like this one. So in actual sense, the sine of 45 and the cos of 45, they're actually the same. Even on our calculator, cos 45 degrees, exactly the same answer that we got. Square root of 2 over 2. So moving on to the tan of 45 degrees, we're still on the angle of 45 degrees. From the ratio of a tan opposite over the adjacent, what is our opposite? That is 1. our adjacent, that is also a 1. So meaning to say this one was going to give us 1/1, which is equivalent to 1. Is it what we are going to obtain from our calculator? The tan of 45 in degrees is going to give us what? A 1. Exactly what we can have from the triangle. So that's why we call these ones special angles or the special triangles, because we obtain exactly the same answers as we have from the calculator, but we can have them from what? From the triangle. So that is it about 45 degrees. The other angles that we are going to work with is 30 and 60 degrees. So these two, they work hand in hand, just like what we had here. Remember, I say these two angles must add up to 90 degrees. So this is 45, this is 45. We've got what? 90, these two. So what about if we have got a right angled triangle like this? All right. We have got a right angled triangle like this. If one of the angles is 30 degrees, the other one definitely is what? 60. Because remember, we need what? 90 degrees. So that is the idea. But where exactly was it taken from? It was taken from an from this one. What do we let's go back to this equilateral triangle. Remember the equilateral triangle where all the sides are equal and all the angles are equal. 60 degrees, 60 degrees, that's an equilateral triangle, this one. So if we are to divide this one into two, all right, let's say we've got the line of symmetry here, cutting this into two, a line of symmetry like this. It divides our shape into two equal parts. What does it mean? It means this triangle on the left-hand side will be exactly the same as this triangle on the right-hand side. So given sides, let's say the sides are 2, this is 2, this is 2. The whole of this side was supposed to be 2, but it is now subdivided into 2. So 2 divided by 2, that will be 1. So we're going to have 1 and 1. And remember, the line of symmetry is at 90 degrees. Dividing the 60 degrees into two equal parts. So it means this one will be 30 degrees. 60 divided by 2. So we're going to have 30 degrees and 30 degrees there. So this will be 30 degrees. This will be 30 degrees. So we are using one of these triangles. So if you check, they're exactly the same. What we see on the left-hand side is what we see on the right-hand side. So I'm going to take this one, which is on the right-hand side, okay? So let's just ignore the left-hand side and take the right-hand side. So we have got a 90 degree. This angle here is what? 60 degrees. So this is where we've got a 60 degree, and this is where we have got a 30 degree, like this. The side is this one is 2. This one is now 1. From this one to this one, we said 1. Remember, it was supposed to be 2 from the equilateral triangle, all sides equal, but it is being subdivided into 2. So this will be 1. This will be 1. So that is 1. So we can calculate the third side using our Pythagoras theorem. All right. Remember, hypotenuse squared is equal to the sum of the shorter side squared. This one that we do not know, let's call it b squared. So this is how we got these ones, guys. So 2 squared, 4, 1 squared is 1 plus b squared. You take this one to the other side, that's 4 minus 1 equal to b squared. So 3 is equal to b squared, introducing the square root both sides. So b will be equivalent to the square root of 3. Meaning to say that's our third side. The third side is the square root of 3. So you can just memorize the triangle, or you can get it from this idea that I'm using. That's how we obtain these triangles, all right? But in case of For you guys, you can memorize these diagrams. Just, okay, no, this is 30, this is 60, 1, 2, square root of 3, 1, 1, square root of 2, from 45, 45, just like that. So we can use the previous idea to obtain the trigonometrical ratios operating from the angle of 30, operating from the angle of 60 degrees. So let's start with the angle of 30 degrees, all right? So putting our focus on the angle of 30 degrees as our reference, using 30 degrees as our reference, this will be the opposite. 30 degrees, this side is opposite to 30 degrees. 30 degrees and 90 degrees, here they are adjacent to each other, whereas our hypotenuse is always fixed facing the 90 degrees. So that is our hypotenuse. So meaning to say, from this, we can have the trigonometrical ratios from the angle of 30 degrees, as I said, just like what we had here on the angles of what? 45 degrees. So we are going to have the same thing, focusing on the angle of what? 30 degrees. So it follows that the sine of 30 degrees from the ratio of sine opposite over hypotenuse. Our opposite is 1. Our hypotenuse is 2. So sine 30 is 1 over 2. Is it that we are supposed to expect sine 30 degrees is what? 1 over 2. Exactly what we can see on our calculator, or 0.5. So that's the same thing. Cos of 30 degrees, the ratio adjacent over hypotenuse. Our adjacent is what? The square root of 3 over the hypotenuse, which is 2. Is it the same answer that we are supposed to expect for the cos of 30 degrees? Square root of 3 over 2, exactly the same answer. What about the tan of 30 degrees? All right, we also have the tan. Remember your 3 trigonometrical ratios, opposite over adjacent. According to tan, our opposite is 1 over the adjacent square root of 3. So that's 1 over square root of 3. So definitely, guys, you rationalize the denominator from the SEDS concept. 1 over square root of 3 multiplied by the denominator, but you multiply both the numerator and the denominator by that square root of 3. So 1 times square root of 3, that's square root of 3. Square root of 3 times square root of 3 is equivalent to 3. Remember, square root of a times the square root of a concept. So that was going to give us square root of 3 over 3 as a simplified value. Square root of 3 over 3. So that's how we name this. Even from the calculator, you're going to have the same answer. So that's the same concept on the angle of what? 60 degrees. With this angle of 60 degrees, we are going to name our sides first. Remember, the opposite is affected and the adjacent. They are affected because of the angle that you were using before. You were referring these ones from the angle of 30 degrees. There is only the longest side, the hypotenuse, which is not affected. So we must go back to the angle that we are now referring, 60 degrees. According to this angle, which part is going to represent the opposite and the adjacent? Definitely the one facing 60 degrees opposite to the 60 is our opposite side. And definitely this will be your adjacent, the remaining one. That's it. So let's have our ratios just like the previous case. So it follows that on this case, from This part, the sine, but referring to what? 60 degrees this time. The sine of 60 degrees can be calculated. So the sine of 60 degrees, opposite over hypotenuse. Our opposite, according to 60, our opposite is what? Square root of 3. This is our opposite. So that's square root of 3 over hypotenuse, which is what? Which is 2. As we can see, the same answer is cos 30. So cos 30 and sine 60 are exactly the same. We move on to cos 60 degrees. According to the angle of 60 degrees, cos adjacent over hypotenuse. According to cos adjacent, which is what? Which is 1 over what? The hypotenuse, our hypotenuse is 2. So that's 1 over 2. Same answer as what? Sine of 30 degrees. Then the last one, which is the tan of 60 degrees. The tan opposite over what? The adjacent. Our opposite, it's square root of 3. Adjacent, it's 1. So that's what we are going to have. Square root of 3 over 1, which is what? Square root of 3. So that is where our special angles are being taken from. So you must know this. But like I said, nothing is being special about these angles since our calculators are advanced to the extent that we can have the same display as what we have got on our solutions, like what we can see. But just that the fact of knowing the previous stage before simplification, because sometimes other questions you must use the previous stage before it is being simplified. But that one we're going to see as we are doing our revisions. Just make sure that you know what you're working with. Understand your basics also as an individual. Do as many questions where the application of these special angles is to be used. Do as many questions as you can. So this is what you're going to have from the 0 degrees, 90 degrees, and those 3 angles, 45 degrees, 30 degrees, and 60 degrees. So let's do revise as many questions as we can as we are preparing ourselves for the exams which are ahead of time.